In this problem, we are given a thin steel plate weighing 10 kilonewtons per meter squared that is being lifted slowly by the cables AC and BC as shown. We are tasked to compute the tension at cable AC in kilonewtons. And to solve this problem, notice that the steel plate doesn't tilt on any other direction. Therefore, we can assume that its center of gravity is assumed to be at this point here once they clear a line or intersect at this point here at C. Now we need to solve for x. There is a distance from the outer edge at A going to the hook. And to solve this, we need to utilize the Brownian's theorem. So first, we need to break down this figure into simpler shapes of rectangles and triangles. Let's call this area here area 1, this one is area 2, and this one is area 3. And let's take point A to be our reference axis. Now to solve for x using Brownian's theorem, the total area times x equal to the summation of all areas times its corresponding centroids. So for the total area, we can solve this by taking the summation of area 1, area 2, and area 3. So for area 1, there is a rectangle that has a area of 2.4 times 4.5 meters. And for area 2, there is a triangle with an area of 1/2 times a base of 3 meters times a height of 2.4 minus 0.6, that is equal to 1.8 meters. Plus this small rectangle here, that's an area of 3 meters times 0.6 meters. Now we can solve for the total area. We have 2.4 times 4.5 plus 1/2 of 3 times 1.8 plus 3 times 0.6. And the total area for this figure is 15.3. And for area sub 1, that's 2.4 times 4.5. That is equal to 10.8. And the distance from the centroid to point A, that is 1/2 of 4.5, which is equal to 2.25. And for the second area, that is 1/2 of 3 times 1.8 equal to 2.7. And the distance going from the centroid to point A, that is 4.5 plus 1/3 of 3 meters. Since the centroid of the triangle going from the base to its centroid, that's 1/3 of the distance or the height of the triangle. So this is 1 meter. So 1 meter plus 4.5, that's 5.5 meters. Plus the area 3, that is equal to 3 times 0.6 or 1.8. And distance going from point A to the centroid of this triangle, that's 4.5 meters plus 1/2 of 3 meters equal to 6 meters. Now we can solve for x. And the value for x, that is 3.2647. meters. So for the tension at cable AC, let's again break down this figure into simpler shapes. So this one has a weight, let's call this W sub 1, and for the triangle, let's call this W sub 2, and this one is W sub 3. And to calculate W sub 1, since we are given the unit weight area for the figure, that is 10 kilonewton per meter squared, we multiply this by the area of this rectangle, that is 2.4 meters times 4.5 meters. This is a value of 108 kilonewtons. And for W sub 2, that is equal to 10 kilonewton per meter squared times 1/2 times the base of 3 meters times the height of 1.8 meters. which is equal to 27 kilonewtons. And for W sub 3, it is equal to 10 kilonewton per meter squared times the area of the rectangle of 0.6 and 3 meters. Which is equal to 18 kilonewtons. Now let's try to locate the distance going from the centroid to this point B. For this rectangle, there is halfway of 4.5, that is 2.25, plus this distance here of 3 meters. Therefore, distance going from the centroid of W sub 1 to point B, that is equal to 5.25. And for W sub 2, the centroid for the triangle going from the base, that is 1/3 of its height of 3 meters. So this value here is equal to 1 meters, giving us a remaining distance of 2 meters going from the centroid along point B. And for W sub 3, that is just 1/2 of the horizontal distance of this rectangle. So this distance here is 1.5 meters. Now, what we need here is the angle theta right here. Since we are given the height of this rectangle of 3 meters and a horizontal distance of 3.2647, we can calculate theta by using the arctangent function. So we have tangent theta equal to 3 over 3.2647. To get theta, we get the arctangent of 3 over 3.2647. That is equal to 42.58 degrees. And then we can solve for cable AC, the tension at cable AC, by cutting on this segment, and then we can expose tensile forces AC and tensile force BC. Now we're taking summation moment at point B equal to 0, considering counterclockwise to be positive. For tension AC, it has a vertical and horizontal component, and since the horizontal component intersects point B, it will induce no moment, only the vertical component of tension AC. So we have tension AC that will induce a clockwise moment, so it's negative, times sine of 42.58 degrees to get its vertical component, multiplied by the moment arm distance of 4.5 plus 3 meters, that is 7.5. And then plus the weight, W sub 1, that will induce a clockwise moment, counterclockwise moment, so it's positive. So let's directly write its value, that is 108 kilonewtons, times its moment arm distance of 5.25. And then plus W sub 2, that is a value of 27 times its moment arm distance of 2 meters. And then plus W sub 3 of 18 kilonewtons times the moment arm distance of 1.5, all equal to 0. Now we can solve for tension AC. So we have negative tension AC times sine of 42.58 times 7.5 plus 108 times 5.25, and then plus 27 times 2 plus 18 times 1.5 equal to 0. We get tension AC equal to 127.69 kilonewtons. And that is our final answer.